All righty. All right. So let me first of all just kind of like, I don't know if I want to, I guess define it is what we'll say here. Okay. And then we'll go do some problems. All right. So an angle of elevation, okay, or an angle of depression, okay, is the angle created between a horizontal line of sight and the actual line of sight. And so, of course, whether you have an angle of elevation or whether you have an angle of depression, it all depends on where the observer is located, right? So let's say, for example, that we have an observer on the ground and they're looking up to something that they spot, like on the top of a cliff. So we'll say like a tree or something like that, a happy little tree. Okay. Since our observer is this person right here, are we talking about an angle of elevation or an angle of depression to observe this particular object? It's an angle of elevation, right? They're looking up. All right. Now, we want to be careful here because the observer, all right, sometimes we want to account, because when we observe as human beings, from where do we observe on our body? Our eyes, right? So when we observe, sometimes we want to be careful and make sure that we do account for our eye height, and sometimes we're not given enough information, so we'll just assume that we're looking from ground level, basically, okay? So sometimes we do want to account for our eye height there to kind of figure out, the height of an object or something like that, but sometimes we're not given the eye height, and so we kind of just do it based on ground level kind of thing, okay? So from our observer here, though, the horizontal would be from the eyeballs, from straight out, right? So there's the horizontal right here. Or the horizontal line of sight, LOS, I guess I'll say. That's the horizontal line of sight, okay, from the observer. And then the actual line of sight towards the object that's being observed here. Okay, there's the actual. Okay, actual line of sight. And then this angle right here, okay, that is the angle of elevation. Now, I'm going to use a Greek letter to describe this angle, okay? The Greek letter is theta, T-H-E-T-A. It looks like this. Okay? It's like a oval with a line drawn through the middle of it like that. Okay, that is theta. Is anyone here taking Greek? Anyone here taking Greek right now? Okay, so I know we have Greek in the school, but I don't know if you guys are at that point yet. I think you have to take Latin 1 before you can take that, so anyway. Okay, that's the Greek letter theta. And it's a typical letter used to describe an angle. Okay, and so in this case, this is our angle of elevation. In this particular problem, it's the angle of elevation. Okay? Compare that to someone maybe standing on a cliff, okay, and they're looking at a boat maybe in the water. Okay. So our observer here, the horizontal would be, again, the horizontal from their observation, and they're going to look down towards that boat. Okay. And again, this angle from the horizontal down the actual line of sight, theta, that is the angle of depression. Okay? Now, in a scenario like this, okay, it doesn't really make sense for like a tree to observe a human, right? But we could talk about someone on the boat observing the person on the cliff, right? In which case, if the boat were the point of reference, if they were the observer, then their horizontal would be right here. And then this angle from their horizontal to the line of sight up to the human, the person up there, okay, that would be an angle of what? From the boat to observe the human, it's an angle of what? Elevation. Okay. How do you think the angle of elevation for the boat to observe the human compares with the human's angle of depression to observe the boat? How do you think those two angles compare? They'll be what? So what's that? They'll be similar. They'll be the same. Yeah, they should be equal to one another. Okay? In fact, they will be. Okay? So the angle of depression to observe something is the same as the thing being observed's angle of elevation. So these two angles here are equal. Okay? So the angle of depression here is equal to this angle of elevation. And likewise here, if someone were at the tree and observing the person down there, the angle of elevation of the person to the tree is the same as the angle of depression of the tree to the person. Okay? So there's that. Excuse me. So let's try some problems here. All right, I think I got 3 for us to do. All right, and that's it. So, situation 1. I'll write it out and then we'll draw a picture and solve it. So a camera, okay, is on top of a fire tower and it sees a fire. If the angle of depression to the fire is 22 degrees, and the tower is 75 meters tall, how far is the fire from the base of the tower? Oh, I'm off the screen. Goodness gracious. There we go. Okay, so the camera is on top of the fire tower and it sees a fire. If the angle of depression to the fire is 22 degrees and the tower is 75 meters tall, how far is the fire from the base of the tower? Okay. So we'll draw a little tower here. Okay, and a little camera. Observing here. We know the tower is 75 meters tall. Okay. And then we'll kind of draw our fire here. Some distance away. We want to know how far is the fire from that tower. Okay. So the angle of depression, what is doing the observing in this scenario? Who is the observer, or what is the observer? The camera. So it is the camera where we should draw that angle. So the first thing we should do is not draw the 22-degree angle of depression. First thing you should do is draw the horizontal. Okay, draw the horizontal. And then from the horizontal, how far down are we going to angle ourselves? How many degrees? From the so from the horizontal, we're going to angle down towards the fire. This measure here is 22 degrees. All right. So now there's a couple ways we can think about this. All right. If the angle of depression from the camera to the fire, so from the horizontal down to the fire is 22 degrees, what will be the angle of elevation from the fire to the camera? From its horizontal, the ground, up to the camera, what will its angle be right here? Also 22. Okay. So then we can create a right triangle here, right? The tower is going to be one leg of that right triangle. The ground, that horizontal distance from the camera to the fire, is going to be the other leg, and the hypotenuse then will be that line of sight. Right there, a right triangle we've created. Okay, right, with the right angle there where the tower and the ground meet. Okay. Alternatively here, you could think of another right triangle as being right here. Okay, it doesn't have quite as much meaning to it, I guess. Okay, it doesn't have quite as much meaning to it, but we can still find, x right here. Okay, from here to here, and solve it this way. So you can kind of set up your triangles two different ways, right, depending on how you like to do them there. But there's kind of two different right triangles you could draw there to help you solve that. But either way, let's stick to the red one for now because I think that one makes the most sense. Okay, how can we relate this 22-degree angle with this height of, I guess I could also have put the 75 height here. Okay. But again, we're going to stick with the red stuff. So in this right triangle here, I have this 22-degree angle. I have the height, this leg here is 75, and I want to find this other leg. What can we use to relate those pieces of information? So, Jenny? No? Never mind. Keep up. Preston? Tangent! Exactly right. And in fact, Preston will say the tangent of what?
22.
Tangent of 22 degrees is going to equal?
75 over x.
Very good. The opposite leg, 75 over the other leg, the adjacent leg, they're x. Exactly right. So there's our setup. Okay, we'll multiply both sides by x to get the x out of the denominator. And then we'll divide both sides by tangent of 22. So we have x is precisely 75 over tangent of 22, but then in our calculators, we'll get that to be approximately I get about 185.6. Okay. And of course, since we're in a context, we're in a word problem, we want to provide units. So 185.6 what? Meters. Very good, because it's a distance. Okay. And there it is. That's our answer. Okay, so here we used tangent. Here we used tangent to solve that one. Okay. Questions on any of that? All right. We'll do one more together here, and then I'll have you guys try one, and then that's it. Okay, that'll be it. So you guys have a good amount of time to get started on your assignment, hopefully, here. All right. Next one. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees. Whereas the angle of elevation to the top of the smokestack is 53 degrees. What is the height of the smokestack? At a point 200 feet from the base of the building, the angle of elevation to the bottom of the smokestack is 35 degrees, whereas the angle of elevation to the top of the smokestack is 53 degrees. What is the height of the smokestack? Okay, so we'll draw a picture here. Okay, got a building. It's got a smokestack. Okay, and we want to find what its height is. Just the height of the smokestack, not the building, just the height of the smokestack. Okay, we have an observer 200 feet from the factory there. Okay, we'll say it's from the ground level, I guess, there too. Okay, so the observer, that's 200 feet away, their angle of elevation. So the observer, okay, this person on the ground, 35 degrees. The horizontal in this case, we'll say, is just the what? The ground, right? Okay, because again, we're not given like the eye height of the person or the height of the object that's doing the observing, so we'll just assume it's with the ground. And so then this angle right here, from the horizontal up to the bottom of the smokestack, is what degree measure? 35. And then from the same location, the degree measure to the top of the smokestack is what? 53. Okay, and of course we're going to assume that that factor makes a right angle there with the ground. So, a little bit different than the last time, right? A little bit different. How can we use this information here to help us find the height of the smokestack? What can we do? Or where can we start here? Anyone have an idea about where we should start at least? Maybe you don't have a full idea about what we can do, but how can we at least start this? Okay, yeah, Madison?
Could you use, you would do the tangent of 53
Okay, tangent.
and 35, I guess.
Okay, of 53 and the tangent of 35, so like two different equations? Okay. So the tangent of 53, we're going to have to label some things here, right? So let's see here. So the tangent of 53, that's going to be this full leg right here, right? Okay, so let's call that, I don't know, let's call it x maybe? Okay. So what will that ratio be then? Tangent of 53 will be equal to what over what then, Madison?
Would be equal to 200, wait, sorry. X over 200.
X over the 200. Very good. Okay. So let's just go ahead and solve that right now. Okay, so multiply both sides by 200, so we get x equals 200 times the tangent of 53. I get to be about 265.4. And that'll be in what units?
That would be P.
Feet. Uh-huh.
So the next is that, and then you do a tangent of 35.
So tangent 35, now what will that give us the height of?
The building.
The building alone. So I'll put that like right here. I'll say that's y maybe. And we'll say tangent of 35 equals y over 200. So y is 200 tangent of 35 degrees, which is approximately 140 feet. Okay. So x is the height of the building plus the smokestack. Y is the height of just the building. And so then how can we find the actual height of the smokestack then, Madison? Go ahead and finish it off. Yeah, subtract, right? X minus y, which is then 265.4, the height of the building and the smokestack, minus the height of the building will get us just the smokestack height. And so we get 125.4. Very good. Whoops. I said that, but then I wrote it wrong. Okay, great job. Exactly right. Okay. Now, we do have, well, actually, I'll ask any questions on that. Okay, so here we have to kind of use two, right? Two trig ratios there to solve for. We do have a small triangle right here, right? We have this little triangle right here. Could we have used sine, cosine, or tangent in this little triangle right here? No, why not? What's the problem with this little triangle? Avery? It's not a right triangle, right? Sine, cosine, and tangent, as we have been using them, right? All the stuff we've learned in this unit so far, Pythagorean theorem, converse Pythagorean theorem, sine, cosine, tangent, special right triangles, it all has to do with right triangles. If it's not a right triangle, we cannot apply sine, cosine, or tangent. Yet. Actually, there will be a way later, I think we'll get to it later, where we can actually apply sine and cosine at least to non-right triangles. Okay, it's called the law of sines and law of cosines. The law of sines is just a little bit more, not really that complicated actually. It's pretty straightforward. Cosines is a little bit more complicated. There's a little bit more to it, but you actually can use them to solve other triangles. So in this case, it's possible that we could have used the law of sines and law of cosines. All right. So, but for right now, you're exactly right. We don't have enough information. All right, last one here. Let me give you, okay, and this will be for you to try. Okay, so our last one here is for you guys. A shark swims 22 feet below sea level. Okay, maybe they're using one of those like radars that fishermen use and stuff like that, or fishers use. If the shark is 67 feet from a sailboat, what is the angle of depression of the boat to the shark? Okay, so there's your scenario. Go ahead. Okay, draw a picture. And I will do the same here. You can round to the nearest degree if you want to, that's fine. Round to the nearest degree. So I think when it says the 67 feet there, it's from the sailboat. So the distance from the sailboat to the shark. So that would be 67.
Oh, very nice shark. I think mine's better probably. No, yours is pretty good too. Okay, here's one.
So the 67 here, be careful, is the distance from the sailboat to the shark. So that would be. Yes. Yes. So you might actually want to draw your vertical from the boat down.
Oh,
At 67 compared to that. So the distance from 67 feet is from the boat to the shark. So don't ask me how we know that in this case, but we know that distance. So it's a hypotenuse.
That's good.
So the 67 feet is the distance from the sailboat to the shark. So it's the direct distance there from the sailboat to the shark. So you actually want to make that hypotenuse. Yeah. So what do we use when we want to follow this off an angle? We always use okay, good. Where's your angle going? Remember that the angle is from the observer, so we have from the observer, which is the sailboat in this case, down. So there's your theta, what your angle, but that would be the same as the angle of the shark's angle of elevation. So they're both the same. Okay, looks good so far. Where's your theta? Where's your angle that you're trying to measure? Right there. So what is the ratio that you want to use? You want to find this angle measure. Be careful. As your pencil. The shark's horizontal is here. So its angle of elevation will be right here. So yes, those two. Those two. Close. The 67 is the direct distance from the sailboat to the shark. The direct distance from the sailboat to the shark. So that's the hypotenuse. Yeah, that was good. Now, where's your angle of that you're trying to solve? Where's your angle of that? So, yes, but it's the wrong angle here. Because remember, an angle of depression, angle of elevation is always from the horizontal. So like from the horizontal here, down, that is the angle. Correct. Or you could use this triangle, because this angle of depression from the boat to the shark is the same as the shark's angle of elevation from the horizontal up to the boat. So you can also say that too, which in this case would still
So I solved it the same way.
same way. But of course you want to use a different ratio because of where you're located, like pieces of information. All right, give me like 30 more seconds here. Any other questions? Any questions before we reveal the answer? Okay, so like I said, 30 more seconds here to give people some time to finish up real quick. Okay. So about 19 degrees there is what you should have gotten. 19 degrees. Okay, 19 degrees. Gets a little bit tricky here. Okay, these problems, it's like, it seems like it should be so simple. We're just drawing a triangle and layering it. But those angled elevation, angled depression problems, it can be tricky about locating those thetas. So again, keep in mind, right, the angled elevation, angled depression, if you're solving for those, it's always got to be, always has to be between a horizontal and your actual line of sight. So consider your observer, consider its horizontal line of sight, and then angle down for an angled depression. Or if your observer is, an angled elevation, consider, horizontal and then angle up from the horizontal to get your angled elevation there. Okay? In this case, with the way I drew my triangle, I actually found the angled elevation for the fish, or for the shark, to the sailboat there. But of course, the angled elevation from the shark to the sailboat is the same as this angled depression here is from the sailboat down to the shark. Okay? So that's all I've got for you there. Questions on any of that? So the remaining time is yours to work on your homework assignment. It is posted to the Google Classroom. There's some word problems there for you to try. Okay. So there's 2 pages. Okay. It's one document, but it's 2 pages. Go ahead and just do the second page. Okay. So all the word problems there from the second page, you can just work on those. Okay. So just completely ignore the first page, please. All right? And I'll adjust that in the assignment for tonight, too. And I also plan on getting some TenMarks assignments for you. I'll figure those out here in just a second. Okay, so there will be some TenMarks. I'm sorry, I know it's going to be Thanksgiving and stuff like that. You're not thankful for TenMarks.
Okay, I don't want mine.